KNES 415, Dr. Campbell here with a quick micro lecture clarification video. I hope this helps clarify some things. Remember, trying to teach you guys more than just stuff we can find in a book. I'm trying to teach you how to think and how to look at things different and help to explain some differences that's in a lot of variability in human movement. Okay, on the test it's going to be very straightforward for these concepts, and then you're going to have the rest of your life to develop them. So let's first start off with a concept of proximal and distal. Distal is further away, proximal is closer to, and in traditional chains, closed, open chain, the intent is the distal segment, the door, moves about the proximal segment, the wall. Typically things go from bigger, denser to smaller and lighter. Think about a building that's super high. The foundation and the bottom floors are thicker and denser than the top floors. Okay, vertebra, our lumbar are denser and bigger than our cervical, which has more motion. So it makes sense that, like, for an arm, the humerus is going to be denser, and then you're going to kind of get out to more thinner bones and then smaller and denser. Like popping a towel, the tip needs to be light and more able to move than getting proximal. Okay, so open chain traditionally is when the distal segment moves about the proximal segment. Okay, so like something like this, something like this, something like this. This segment, this rigid link, moves about this one. This one is smaller. This one. So in other words, this one could be distal to my humerus. My radius and ulna could be distal to my humerus, but my radius and ulna could be proximal to my carpal bones. Make sense? So my radius and ulna, my forearm, could be the wall for this, but it could be the door for that. Okay? Closed traditionally is when the distal segment is fixed, so the smaller part is fixed, the door is fixed, and then the proximal pieces have to move about the distal pieces. Okay, so if my hand was up against a wall, I couldn't just move my hand because it's fixed, it's anchored. Okay, so closed chain is when you move proximal pieces about a distal piece. I think the easiest example is like if you were doing squats or air squats or weighted squats, where your lower legs move about your feet. You don't have your feet move about your lower legs, you have your lower legs moving about the feet. Okay? So what I want you to notice with these common sense kind of trends, open chain, distal segment moves about the proximal, closed chain, proximal segment moves about the distal, is that we have two main types of movement patterns. We have simultaneous movements, which is two or more joint motions happening at the same time. Okay? We very, very profound for linear motion of the distal segment or you. So in other words, if I'm closed chain doing push-ups, isn't my center of mass going linearly up and down? Okay, simultaneous motion, great for linear movement, but the reason I need two or more is because individual joints by themselves are angular, and by angular they're trying to rotate me and translate me. They're actually trying to go away from where you're trying to go. Simultaneous movement, I did the jab analogy. Simultaneous motion helps me to linear translate my punching hand. But it's because of rotation of my elbow and rotation of the shoulder happening at the same time. Okay? So we have multiple joint motions done at the same time. Then we have angular. Now, you say, well, Dr. Campbell, all joint motions are angular. Yes. But when you have two joint motions canceling each other's angularity out, they can work together to summate translation of another segment. Okay? So when I say Angular, it's one joint motion happening at a time. So even in complex sequence motion like pitching, we have one motion at the joint happening at a time. Okay? So sequenced, angular without summating, without canceling out and translating a distal segment. So it's angular. If one joint motion, if all my wrist does is rotate, I'm going from 9 o'clock to 12 o'clock to 3 o'clock. Does that make sense? If all I do is move my elbow, I'm going from 9 o'clock to 12 o'clock. But if I move my elbow and my shoulder, does that make sense? Okay. So one at a time, it's going to just be rotational if I'm only rotating one joint at a time. Sequenced, one is a sequence. And then we have open and closed, distal, proximal options for both. Now, again, for the text, I'm not going to ask you to identify anything other than the ones we go over in class. Okay? So I'm going to give them to you right now. So an example of a closed exercise, meaning it's closed to straight line motion of my distal segment because of simultaneous motion, two or more joints. Closed, meaning that my distal segment can't translate. I gotta, if I'm strong enough, I gotta translate my proximal segment about my distal, like during a push-up. A push-up would be closed to linear of my distal segment, but it would also be closed to angular of either my elbows or my shoulders because of friction. Thanks, friction. Because my distal segment is compressed, I'm not going to be able to shift or slide my hand. If my elbows move, my shoulders got to move. Does that make sense? Now, none of these exercises that I'm going over is not meant to say this is better than that, that's better than this. It's not about that at all. It's about what is the distal segment allowed to do. And during an exercise like the push-up, my hand is not allowed to go straight, and my hand is not allowed to go perpendicular to straight. Those roads are closed. Okay? Now, something like this, the dumbbell chest press. Call it whatever you want, call it Charlie. Now, we have a lot more roads that are open. The distal segment, the hands in this exercise are open to go in straight lines. And also, the distal segment, the hands are open to go one at a time. I could just move my elbow. Friction's not closing that road. I could just move my shoulder. So what are the differences? Movement patterns, motor programming. It's harder to be accurate. That's why sometimes you need a spotter. You know what a spotter does? Helps close the roads to make sure you're going in a straight line, because it's hard to go in a straight line when you're on skates, when you can go all over the place. Okay, so that's why we typically don't start off with this kind of exercise with novices or first timers, because all their roads are open. It's hard to kind of go straight when you have all these different options. Okay, it's like driving for the first time in a parking lot, empty parking lot, versus like having lanes that you can kind of steer in. Okay, all right. So that's an open to straight line of the distal segment, but also open to individual sequenced angular of any of those segments as well. Okay. Here's an example of open to straight line, but closed to sequenced, meaning it will allow you to move simultaneously so that make your distal segment go straight, but it won't allow for individual, one at a time joint motions that would have thus taken you purely angularly. Here's an example of that. The chest press machine. Notice, if your hands go out, you're moving elbows and shoulders. Your hands come closer in, you're moving elbows and shoulders. The machine allows you to move just like a dumbbell chest press, but the machine doesn't allow you to move all the way like a dumbbell chest press. It's closing those angular roads, those individual, one at a time joint motions that might have taken you all over the place. It's helping you establish motor programming. It's helping you to learn how to drive. Open to linear, closed to angular, open to simultaneous, closed to sequence. Kind of all or none, if you want to look at it like that. Okay. Now, what are a couple examples of closed to linear, but open to angular? There's a couple. One is a slide board, could be considered closed open. You're not going to push through the ground. However, now that we've minimized friction, you could just move your elbow. You could just move your shoulder. And people will do this with the wall too. If you haven't progressed to that in rehab, where you can have wall slides where you minimize friction and you can move perpendicular to the push. Okay, that's one example. Another example could be a machine that doesn't allow you to go in a straight line, a machine that only allows you to rotate one joint. So like a fly machine where you can only move the shoulders because you're working chest. So push up, chest. Now if you say, well, what about the elbows? I could find an exercise that isolates just the elbows, the elbow extensors, so the triceps. But I chose the chest. So in the push-up, you're working chest and triceps. So if you're going to isolate one at a time and close the simultaneous roads and keep just one of those roads open, either the elbow or the shoulder, got to pick which one you want. In this one, I picked the shoulder road. I only want the shoulder road to be open. I can't force the machine to do this. I can't force the machine to go in a straight line. That road's closed. The machine forces me to only rotate. Okay? So on the test, it's literally going to be those examples. It's going to be all chest stuff, push-ups, machine chest press. Like, all I'm asking you to communicate is that you know the difference between these four options. Open, open, closed, closed, open, closed, closed, open. Cool. Hope that helps.